Hey everybody, my name is Calvin and welcome back to my channel. Today we'll be talking about data wrangling with pandas. Data wrangling is one of the most important parts of data science because real-world data is almost never clean when you first get it. A lot of beginners might think that data science is mostly about building machine learning models, and that's true, but a huge part of the work is getting the data into a usable format. That means reading data, understanding the structure and schema, fixing missing values, and stuff like that to prepare the dataset for analysis. In this tutorial, we're going to be exploring how we can perform common data wrangling operations at scale. Also, real quick before we jump in, if you've been enjoying the content on this channel and want to support what I'm building here, check out my book Modern Data, From Ingestion to Production. It's a practical introduction to how data moves through modern systems, from ingestion and transformation all the way to production use. It's available on Amazon, Barnes & Nobles, and Apple Books, and the ebook is only $6, so it's a really affordable way to support the channel and learn something useful at the same time. Be sure to check out the links in the description. Let's get back into the video. When working with data in Python, one of the most common file formats you will see is a CSV file. You might have seen it before. CSV stands for comma separated values. That means the data is stored in rows and columns, kind of like a spreadsheet. Each row represents one record, and each column represents one piece of information about said record. For example, imagine we had customer data. It might look something like this. Notice how every value is split, using the comma as a delimiter. The first row contains the column names. Then each row after that contains one customer. The format is very simple, which is why CSV files are used everywhere. But CSV files are just plain text files. They don't automatically understand data types, missing values, categories, or any kind of business rules that you have set up. That is where Pandas comes in. Pandas is one of the most popular Python libraries for working with structured data. When we load a CSV file using Pandas, Pandas usually stores that data in something called a data frame. A data frame is basically a table in Python. You can think of it like a spreadsheet, but much more powerful. A data frame has rows and columns, and Pandas will give us the tools needed to filter, clean, transform, summarize, and then ultimately analyze that data. The basic flow is from CSV file, then Pandas will read the file to a data frame, and then to your large-scale data wrangling. To start, we have to install the Pandas Python package. We can do it using a simple pip command. I have this set up so Pandas will be installed into my virtual environment. Now that Pandas is successfully installed in my virtual environment, the next thing we have to do is import the Pandas package. And we can do it using a simple import statement, import pandas as PD. A key thing to know about the import is that we usually import pandas as PD because that is common convention. You'll see it everywhere. That means every time we want to use pandas, we can write PD instead of typing out the word pandas. For this tutorial, let's create a small CSV file for ourselves. In a real project, you might download a CSV file from Kaggle, export one from Excel, or receive one from your database or business system. But for learning, it helps to build a small example first. And that's what this code will be doing. Here, we're creating a Python dictionary where each key becomes a column name. Each list becomes the data inside that column. Then we pass that dictionary into pd.dataframe. Here, now we have a data frame called df. This is the main object we'll use throughout the tutorial. And you can see, if we examine the df, we'll see our dictionary put into a nice table. Let's actually save this data frame as a CSV file. And we can do that using the pandas to CSV method. And we'll have it be saved into a CSV called customers.csv. Let's run this. And we can see that now we have our CSV files. Now that we have our CSV values in this file. Now, what if we wanted to load this into pandas? The function pd.readCSV, right here, will read a CSV file and then turn it into a data frame. Now, the variable customers contains our table. This is usually one of the first steps in a data science project. You'll load your data, inspect it, and then start cleaning it. When working with a new dataset, you usually don't want to print the entire thing right away. Some datasets have thousands, millions, or even billions of rows. Instead, we can use the head method. By default, head shows the first 5 rows. We can also choose a specific number of rows. Say we wanted only 3 from the top. And all we had to do was put in a number within the parentheses. The same idea applies to the tail method. Here, tail will show the last few rows. It's simple commands, but they are very useful when quickly checking what your data looks like. Now, we should check how many rows and columns are in the data frame. Here, we can examine the shape attribute of customers. The first number here is the number of rows. The second number is the number of columns. We have 6 rows and 6 columns. And we can confirm that by jumping over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We can also look at the column names, and we can do that by examining the columns attribute. Customer ID, name, age, and city, and total spent. Let's check the data types. We can use that by the dtypes attribute. Customer ID is an integer, name is a string, age is a float, and so on. Another useful command is info. This will give us a summary of the data frame. For numeric columns, we can use the describe method. This will give us summary statistics. Here we can see things like the standard deviation of age is 5.744, and the mean total spent is $141.25. Now, if we want summary statistics for all columns, including text columns, all we need to do is set the include variable in here to all. We should also check if we have missing values. Real-world datasets often have missing values. Pandas uses NaN to represent missing data in many situations, and we can check for missing values with the isNa method. You can see in our third row, we have a missing value. True will mean the value is missing, and false means the value is present. But this can be usually hard to read, so we usually combine it with sum. And we see missing value in age, a missing value is present in city, and there's a missing value in total spent. There's a few common ways to handle missing values. One option is to remove rows with missing values. We can see here that we had 6 rows, but we dropped 3 rows because of the 3 missing values. We dropped the entire row. It's simple, but this can be a dangerous approach. If your dataset has a lot of missing values, you might accidentally remove too much data. Another option is just to fill in the missing values. For example, we can fill in missing city values with unknown, and that's what this is going to do. Fill NA, and we pass in the string unknown. For customers in city, for the city column, we're going to fill in all not a number values with the string unknown. Now for numeric columns, we might fill in missing values with a mean, median, or 0. Here, all we'll do is fill in the missing age with the mean of all the other ages. And that's what this will do. We set the value to be in the fill NA method to average age as we define it up here. For total spent, maybe we'll decide that missing value should be treated as a 0. And here we just hardcode 0 in here. Again, the right choice here will depend on the context. You should think about what the missing value means before dealing with any missing values. Another common task is to rename your columns. Say we wanted to rename total spent to total spent USD. Here, we're going to be defining 2 columns. The first thing here is total spent, which is our existing column name. And here we can replace it with a string called total spent USD. And that's here, the rename method will take in these as parameters. We can run this, and we can see now that our column name is now total spent USD, whereas before it was just total spent. We can also quickly examine to see if our code before worked. We can also see if our code above worked. Here you can see that this missing value is now filled in with an unknown. Total spent USD is now a 0. Sometimes we only want to work with certain columns. To select one column, we can do customers square bracket and the name of the column. This will return a pandas series. A series is basically a single column. To select multiple columns, we can use double brackets, like this. We have this list of name, city, and total spent within another pair of square brackets. We can run this, and we can get only the 3 columns that we're interested in. Filtering rows is one of the most important parts of data wrangling. For example, let's find customers who spent more than $100. Here, we're going to have a variable called high spenders. In the customers table, we're going to be using the total spent USD. If the total spent USD value is greater than 100, we want to keep that. We can print this, and we'll keep the rows right here where total spent is over $100. This line right here creates a condition. It's basically saying if the value in total spent USD is greater than 100, we want to keep this. This will return true. Otherwise, return false. We can also filter by text with the same idea. Say we're only interested in customers in Boston. Now, what if we wanted to combine both? What if we wanted only New Yorkers who have spent over $100? Here, we can see that Fiona is the only one who matches the criteria that we had set. Another thing to note here is that the way we put conditions together, here, we use this ampersand for and we'll also use the vertical line symbol to denote an OR condition. Here, we want both New Yorker and total spent. We want both of these conditions to be true, but if we wanted one or the other, or both, we replace it with a vertical line. Now, that basically is saying, now if one of these conditions is true, doesn't matter which, we want to keep that. And we can see that that's reflected here. Now, what if we wanted to create a new column? Data wrangling often involves creating new columns from pre-existing ones. For example, maybe we want to create a column that labels whether someone is a high spender, and this is going to be true or false. Here, we're going to define customers with the column is high spender is equal to customers with the total spent USD greater than 100. It's going to set this value for every value in the is high spender column. Now, we have a Boolean column called is high spender with true or false. We can also create categories using a function. Here, we define a function called spending category. If the amount spent is greater than or equal to 200, we return high. If the amount is greater than or equal to, we have medium. Else, we'll return low. Here, we'll use .apply to apply that function to every value in the total spent USD column. Let's run this, and we can see now we have our new values in here. We have spending category, medium, low, and high. Now, with these new columns, let's check the new data types. Here, we see sign up date is a string. That means Pandas is treating it as text. Here, we want to convert it into a real date time object column. Here, we'll use the toDateTime method to turn the sign up date column in customers to a datetime object. Now, Pandas will understand this column as a date. Now, whereas we couldn't have before, we can now extract pieces of the date like year, month, or day. can see sign up month, sign up day, and the sign up year. We can also sort the data frame by a column. For example, let's sort customers by total spent. Here, we'll use the sort method values by total spent USD, where it's descending, in descending order. Here, we want the largest values first. We can see 300, 150, 120, 89, 45, and 0 are successfully sorted. Now we can just set ascending is equal to true for it to be actually ascending, so basically the opposite order. Low to high. Another powerful Pandas operation is group by. For example, let's calculate grouping lets us summarize data by the category. For example, let's calculate the average amount spent by city. Here we'll do group by on the city column with the mean of the total spent. For Boston, the mean spend is $60.25. For New York, $120.37. Unknown, $300. Chicago, $45. Using this, we can also calculate a few statistics. The same idea applies here, but we'll get the count, mean, and the sum. The mean here is $60.25, as we found out before, but now we'll also have the sum, $120.50, total that's been spent. We have two New Yorkers with a mean spend of $120.37 with a sum of $240.74. This is very useful for data analysis. A lot of business questions are basically group by questions, like what is the average revenue by region? How many users signed up for each month? Which product category generated the most sales? Which customer segment spends the most? Group by can be used to answer those sort of questions. Sometimes after grouping, the grouped column becomes the index. If we wanted to return back to a normal column, we can just simply use the dot reset index. Now, city is now just a regular column again. As you can see so far, our dataset is very small. It's a toy example, but Pandas is also used for much larger datasets. And the nice thing is that most of the code will look exactly the same. Whether you have 6 rows or 600,000 rows, the basic operations are very similar. That's why Pandas is so useful. You can write clear, readable code that transforms a ton of data at once. You don't have to manually loop through every row in most cases. Pandas operations are designed to work on entire columns and data frames. I want to cover a couple of pitfalls that beginners often make. A common beginner mistake is trying to process data frames one row at a time. For example, beginners often want to write a loop like for row in customers, print row. But this does not work the way people usually expect. In Pandas, we usually think in terms of columns and vectorized operations. So instead of saying for each row, check if total spent is greater than 100, we can say something like customers is high spender is equal to customers, the column total spent USD greater than 100. Another common wrangling data task is cleaning text. Let's say the city names might have some extra spaces or inconsistent capitalization. For example, let's say we had a leading space in Boston, all lowercase, all uppercase New York, with a trailing space, and we just have a regular, actual, correct name. Now we can see our data frame reflects this bad data. Here we can just simply clean the city column using string methods. We're going to be taking a look at the city column, and we're going to just do the strip method. And here we're also going to apply title rules to it. So we capitalize the first letter and lowercase all else. And now we can see that our data is now usable. Another common issue is duplicate rows. We can check for duplicates in our data using the .duplicated method. This will return true for duplicate rows. We run this, and we can see that there is no duplicate rows. If there was a duplicate row, we'd get true. What if we wanted to count the amount of duplicates? We know that there's 0, but all we need to do is use the sum method on it. And we get 0. And what if we wanted to remove duplicates? All we would need to do is use this drop duplicates method. Sometimes you might only care about duplicates based on a specific column. What if you think that customer ID should be unique? Here, we just pass in the subset is equal to customer ID, and here, we'll remove the rows where the same customer ID appears more than once. Handling duplicates well is very important as part of the data quality. After cleaning and transforming the data, we'll want to save it. Here, we'll just use our toCSV method again, and we'll save this into customersclean.csv, like before. Again, remember the common workflow. Raw data in, then we clean and transform with pandas, and then we'll get clean data out. So that was a beginner-friendly introduction to data wrangling with pandas. The big idea that you should take away here is that raw data is usually very messy. It's 90% of the job as a data engineer. Before we can do any analyzing of data or building machine learning models, we have to make sure our data that goes into these applications is clean and in a useful format. In this video, we covered how data is commonly stored in CSV files, how Pandas loads that data into a data frame, and how to perform common wrangling tasks like checking missing values, filtering rows, creating new columns, grouping data, and exporting cleaned results. Once you understand these fundamental basics, you can start working with much larger datasets and more realistic data science projects. Thank you for watching, and I'll see you guys in the next video.